Good morning, everyone. What I'm going to cover this morning is just some basic assembly and system calls. You really need to know about system calls before you get into making payloads and such. And it's not that far off from making basic bin shop payload. So what I will do is take you into my machine and let's go over to Linux. Okay, so here in the data section, this is for your defined data. You got the BSS above it for your undefined data. And we just have an ASCII string here in message saying Lee rocks, okay? The text section, this is your executable. This is start. The start's sort of like the main in C programming. And all this here is the assembly code to get Lee rocks printed into the screen. So I'll show you how I figured all this out. The first thing you're going to have to do is check out std underscore 32.h. Let's locate, and I'm going to take this one here. So to figure out how to write, you sort of have to figure out the system call numbers. So we will come over here to this file right here. And as you can see, this is a list of all the system call numbers. And you need this to start off with. I know syscall for write is 4 because I've already done that. But the easy way to do it is just put in a pipe and grep for write. And then you can see right here that it's defined as 4 for the write. Okay, so what else we'll do? First thing you need to find is your syscall number, and that's your syscall call number. We're going to push that into the EAX register. Once you find that, then you can have a look at man2 for write. Now, this is the Linux programmer's manual. And as you can see, the thing you have to grab from this is what arguments you have for write. So the first one here is an integer for a file descriptor. So we're just going to use one for that. You have a buffer pointer here, so this will point to the message you want to print. And then the third argument, is the count. So that's the size of the program. So let's go back over to my program and close the terminal and let's have a look. So this first EAX right here, this is moving 4 into EAX. So that's our syscall write number. So this is saying setting up the write. The next variable, which gets pushed into the EBX register, and this is the way it's always done with syscall. So the first variable gets pushed into the EBX register, and the file descriptor is going to be 1. The second argument that we came across was the buffer pointer. So this needs to be pushed to ECX and point it towards our message right here. Okay, so when we get down here to the EDX, the third variable, as we've seen in the man2 page, this is the size of the string. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So 12 is the size of this string. Interrupt, this basically is, in 64 it's called syscall. In 32 it's just 0x80. And this pushes all this and calls it and does the write for you. This right here is an exit, so you don't get a segmentation fault, and it's just basically closing the program down. So this is the actual hello world in assembly right here, and this is to exit the program normally. Every program will have one of these. Okay, so what I will do is show you one more thing, and that's the return um, into EAX. So what I'll do, I'll just open up GDB. I'll put in Q to quiet down all the comments. And I think I called it Hello World. Okay, so what you can see here now is I will disassemble the start. And here's our program we were just looking at. So the first thing I'm going to do, I'm going to put a breakpoint in at start. I'm also going to display $EAX. So now it'll show us our EX. What I want to show you is the return value once the function is done. So I'm also going to display two integers of EIP, which is the index pointer. And now I'm just going to run this program. So as you can see, EAX is still 0. We're at the very beginning of the start. So next instruction, now all of a sudden you see EAX is 4. What that 4 is, remember, it's the syscall for write. Okay, so what we will do, we will hit the next instruction. And as you can see, we're moving along here. EAX hasn't changed. EX hasn't changed. And all of a sudden, once we get down here to where the interrupt's been called and the write syscall has been executed, we get a return here in our EAX of 12. The return value for the write gets put into EAX at the end of the call, and this is the size of what was written to the screen. So that's something else for you to watch out for. This is just some basic assembly for you guys, and I hope you guys enjoyed. But this is how you write to the screen with a basic assembly program. So I hope you guys enjoyed, and I will chat to you guys later.